Hello, welcome to all of you. Now, after completing the errors and the correction, understanding the concept of errors and correction, we will move to the what type of errors is coming when we are measuring with the chain. When we are measuring the certain measurement with the chain. When we are talking about chain measurement, actually there are two types of errors and the two types of corrections are needed accordingly. First one is the correction for standardization. First one is the correction for correction for standardization, and the second one is correction for slope. Correction for standardization, it means that when we are standardizing something at particular conditions like the particular temperature and pressure, we say that at this very particular, the length was this, the temperature was this, the pressure was this. Now at site the temperature cannot be the same, the pressure cannot be the same, or other conditions which we actually take as standard or cannot be the same. Then we need correction for that very particular things. So here comes the concept of correction for standardization. And the second thing is correction for slope. We have many type of errors, but actually when we talk about the measurement done with the chain, there are the main two. So for this, the first one, when we talk about the correction for standardization, what we say simply the true into true is equal to wrong into wrong. This is a concept. True into true is equal to wrong into wrong. What does this mean actually? It means a true length into true length is equal to wrong length into wrong length. Wrong length into wrong length. This is a concept of this total what we can understand. But actually the true length, or can we say the nominal length? The names can be anything, but actually you should focus on the concept. They can change the meaning of the terms in the question, but when you get the concept, actually you can solve the problem in a very good way. Then we have CT. This is the true length of a chain or correct length of a chain, for example 20 meter, 30 meter. And W is the wrong measurement you get by using the measurement. Suppose you get the measurement, the true measurement was 500 meter, you have to measure the 500 meter length, but you actually measure as 502. That was the incorrect length as 502 meter. And another one wrong is the wrong length of a chain. Another one is the wrong length of a chain. Suppose the change was here 20.05 meter for a 20 meter chain or tape. So that is the wrong measurement here for the chain. Suppose the correct length is L. This correct length L will be equal to the actual length of chain. Correct length will be the actual length or length of the chain which you measure into number of times, how many times you measure the things. That will be correct. Correct length will be equal to the actual length of a chain, number of times you measure with that very particular chain. So if I suppose the correct length is L, then this will be equal to the if L is the wrong length and what you measure with a wrong measurement, then it will be the true length of a chain or tape. That means L into L is the correct one, and L dash into small l, L into L, and L dash into L dash will be the incorrect one. So here comes the correct length becomes this. Correction will be correction if you are going to if I measure the length as L. The correction will be correction for this very particular will be equal to C. That will be equal to true length and minus you measured length. True length minus measured length, as I have already said in the previous one. Here the true length is L dash into L dash divided by L, and measured length, what you have measured length is L dash. When the correct length was L, but you measured as L dash. So true length minus measured length, will be the correction here. So when we solve it, if L comes in common, that it becomes L dash by L minus 1. L dash minus 1 by L. That becomes equal to L dash into L dash minus L divided by L. That is equal to correction here. This is equal to correction. यानी कि सिंपली अगर आपके पास ये है कि आपकी करेक्शन मिलेगी, आपने जब सपोज़ आपकी जो लेंथ थी वो 500 थी, लेकिन आपने 502 मापी, कितनी मापी? 502 मापी, लेकिन यानी कि आपने 2 मीटर ज़्यादा मापा, 2 मीटर आपने ज़्यादा मापा, तो दैट 2 मीटर विच मेजर मोर, जो आपने ज़्यादा मापा, तो दैट 500 minus 502, 500 minus 500, that is minus 2. You have to subtract the 2 meter from the length, so that you can get the actual 500 result here. This L dash, sometimes they can call it true length, they can call it nominal length or anything. You have to be very firm on the concepts, not on the terminology used. Similarly, if you have to calculate the true area from the same concept, the true area will be equal to that L dash by L upon L square into the measured area, and the true volume or corrected volume will be equal to L dash by L cube into measured volume. These are the formulas which you will be required to solve the numerical problems. The second thing here is the correction for slope, CD, or C, correction for the grade, or correction for the slope. Similarly, suppose this is the suppose this angle is theta, and the correct your distance linear is this one. This linear distance is L. Suppose this distance you measure is L, but the correct linear distance you have to know is D, D. Then at type of you measure L. You did not measure D, you measure L. When you measure L minus D, it will show the value. That value is called the error. But what you need is here correction. Then correction for this very particular slope will be opposite of this, and that will be equal to D minus L. And I have already said that this very particular D can be go, if this is a theta, then D is called to L cos theta. So from here, L cos theta minus L, it will be equal to L into cos theta minus 1. And this can be written as CG is equal to minus L 1 minus cos theta. This is the correction for slope. After that, if we have given the differences, if in the question he has given me this h, the height, the difference between this ground level and the elevated level, at that time the CG will be same as what we have already said, that it will be D minus L. This D will be, at that time it will be equal to L square minus H square. At that time this D will be equal to, because it's a base, and it will be equal to hypotenuse square minus perpendicular square, and L is our, what we have seen is firstly. Then CG or CS will be equal to the L 1 minus H square upon L square ka whole square 1 upon 2 minus 1. If we are going to make the common here L, then taking the L from there, it becomes 1 upon H by L square upon 1 by 2 minus 1. Then by using the binomial, this CS will become 1 minus H square by 2 square, H square by 2L square minus H4 by HL4. You might know the concept of binomial, as you have already learned it from the mathematics, and it's the basic mathematics. If you don't understand this very particular step, go through the binomial series, then you will understand this very correctly. After that, if you are going to neglecting the smaller terms here, HR, FL4, and the higher terms, what we get simply is CS will be equal to minus LH square by 2L square. That is equal to H square by 2L. At that time, the correction will be H square by 2L. This very particular here is negative. The slope correction is always negative. If you are going to go by the one way or the second way, the slope correction is always negative, because slope distance is always greater than the what we get from the linear distance. When the distance is more, you have to subtract that very distance to get the correct distance. That therefore the correction due to slope is always negative. That means you have to subtract this from to get the exact values. And the second point about this is, in some questions they have asked about the, if the higher terms are not neglecting, if we are not going to neglect the higher powers, the correction will be increased by how much time it will be increased or decreased. It will be increased, the correction will be increased from the above setup. You can see the correction will be increased as AH4 8L cube. In some examples they have asked this very particular also, so you will note it. So these were the main corrections needed for the chain. If we have tape, then the other corrections needed will be the correction for standardization will be required. After that, with the correction for slope also be required, and the extra corrections which you need is correction for pull. This is the component correction for pull. The fourth one is correction for temperature, which can be both positive and negative depending on the temperature. And the fifth one, that is correction for sag, which is always negative, and it is cumulative error, correction for sag. And the sixth one is correction for misalignment, that is also the cumulative error, correction for misalignment. The seventh one is correction for mean sea level. The first and second one I have already taught about those. Then go to the third one directly. The CP for correction for pull is given by P minus PS by AE. PS minus P minus PS by AE into L. The CP is correction for pull. The PS is standard pull. A is the area, is elastic modulus of a tape, and this very particular L is a major length. This is a major length. P minus PS upon AE into L. PS is a standard pull, and P is the pull applied during measurement. P is the pull applied during measurement. During measurement. Are you getting it? This very particular correction is always a positive. Isn't it? This is not true, because it will depend upon the magnitude of P and PS. If P is more, then CP is positive. If P is less than PS, then CP will be absolutely negative. The fourth one I can discuss here is correction for temperature. The CT correction for temperature is simply given by alpha T measured minus T naught into L. Alpha into Tm minus T naught into L. CT is again correction for temperature, and the Tm is mean temperature during measurement, and T is a temperature for standardization. And the alpha is a coefficient of linear expansion. This alpha is equivalent to 3.5 into 10 to the power minus 6 per degree Celsius for steel tape, and this alpha is equal to 1.22 into 10 to the power minus 7 per degree Celsius for invert tape. So it is comparatively less for the invert tape. This is also positive if the Tm is greater than T naught, and if T naught is less than Tm, it will be negative. Now the next one is correction for sag. Correction for the sag. Why we need actually this, and sometimes what we do is, when the accuracy needed is more, what we do, accuracy needed is more sometimes, then what we do, rather than laying the tape along the ground, it is suspended between the two tripods. When it is suspended between the two tripods, hung in catenary, that is called hung in catenary, then the correction for the sag is applied. In the tape, if the tape has been standardized on the flat. What does this actually mean? मतलब यही है कि आपने स्टैंडर्डाइज किया है इसको ये लेंथ मापने में, लेकिन आपने जो क्या है क्या अपने साइड पे ऐसे कैटेनरी में इसको हंग किया है, तो ये डिस्टेंस ज़्यादा आएगी, ये तो सीधी बात है। लेकिन चाहिए आपको ये, तो इस टाइम आपको क्या करना पड़ता है कि आपको ये करेक्शन जो है GRC सैग बोलिए आप इसको आपको कम करना पड़ता है, नेगेट करना पड़ता है। तो आप इसको जो आती है हमारे पास ये दैट इज़ W²L³/24 W²L³ 24 यहाँ पे हमारे पास जो W है स्मॉल w, इट इज़ अ वेट ऑफ टेप पर यूनिट लेंथ, इट इज़ अ वेट ऑफ tape per unit length, that is in Newton per meter, and the L is the length of tape suspended, P is the applied pull, and this correction is always negative if you have standardized your tape in the ground, in the horizontal ground, and you are measuring this very particular length in the what we say is in the catenary. But if the tape is standardized is in catenary, if it is given in the question that the tape has been standardized in catenary, इसमें catenary में ही standardize किया गया है, उस टाइम पे आपकी करेक्शन क्या आएगी, उस टाइम पे आपकी करेक्शन जो है वो पॉजिटिव आएगी। करेक्शन ये नहीं आएगी थोड़ा डिफरेंट आएगी, लेकिन वो पॉजिटिव आएगी। वो आपसे पूछेगा नहीं, गेट में अभी भी पूछा नहीं है, लेकिन ये पूछ सकता है कि पॉजिटिव आएगी या नेगेटिव आएगी। क्या पूछेगा कि अगर आपने टेप को ऑलरेडी स्टैंडर्डाइज किया है कैटेनरी में, लेकिन आप उसको फ्लैट इस्तेमाल कर रहे हो, सीधी बात है, आप उसको फ्लैट इस्तेमाल कर रहे हो, तो उस टाइम पे आपको माइनस नहीं करनी है, करेक्शन आपको प्लस करनी है, ठीक है। उसके बाद मेरे पास आता है करेक्शन फॉर मिसअलाइनमेंट। सपोज आप क्या कर रहे हो कि आपकी ट्रैवर्स लाइन है, फिर आप यहाँ से गए, फिर आप यहाँ से ऊपर गए, फिर नीचे गए, तो आपको चाहिए थी ये वाली लेंथ, लेकिन आपने यहाँ से ये मापी, फिर यहाँ से ये मापी, तो इस टाइम भी आपको क्या करना पड़ेगा, आपको सिंपली एक करेक्शन फॉर स्लोप जो लगा रहे थे आप, उसको आपको क्या करना पड़ेगा, लगाना पड़ेगा। तो आपको सिंपली अगर ये मेरे पास A है, ये मेरे पास B है, ये मेरे पास C है, आपको क्या करना पड़ेगा, आपकी जो करेक्शन है वो सिंपली आएगी, मैं माइनस को कॉमन करूँगा यहाँ से, AB × 1 माइनस ऑफ कॉस ऑफ अल्फ़ा प्लस BC 1 माइनस कॉस बीटा। अगर आपके पास जो एंगल्स हैं वो ये आपके पास अल्फ़ा है और ये आपके पास बीटा है, ये आपके पास अल्फ़ा है और ये आपके पास बीटा है। उसके बाद जो करेक्शन आती है, दैट इज इक्वल टू करेक्शन फॉर मीन सी लेवल। तो अगर ये वाली करेक्शन पूछेगा आपसे तो आपको सिंपली क्या करना है, दिस करेक्शन इज इक्वल टू LH/R प्लस, और ये भी नेगेटिव होती है हमारे पास, ये भी, लेकिन R बहुत ही ज़्यादा होता है एज़ कम्पेयर टू H, इसलिए हम सिंपली इसको लिखते हैं -LH/R। और ये पूछा गया है बहुत बार कि जो करेक्शन ड्यू टू किसके बराबर होती है, करेक्शन ड्यू टू मीन सी लेवल होती हैं, वो हमारे पास वो डायरेक्टली प्रोपोर्शनल टू H होती है, दिस करेक्शन इज डायरेक्टली प्रोपोर्शनल टू H। तो ये H क्या है, ये आप मीन सी लेवल से आप जितना भी ऊपर जाते हो, जितना भी कोई चीज़ मापते हो, ये H वही है, ये उसके डायरेक्टली प्रोपोर्शनल होता है। और यहाँ पे R जो है वो R रेडियस ऑफ द अर्थ है, दिस इज इक्वल टू द करेक्शन फॉर द मीन सी लेवल, ठीक है। तो आज के लिए हम इतना ही पढ़ेंगे, उसके बाद देखिए कि जो भी टॉपिक रहा होगा और जो भी क्वेश्चन रिलेटेड आए होंगे उनको हम देखते हैं। तब तक के लिए शुक्रिया।